All right. Hi, everyone. Welcome to this session, which is Building Technical Know-How Through Innovation, Seed Funding, and Community. We have a couple goals here today. So first of all, Aaron Fries and myself, who are co-conveners, and Leah Calaswano, who is also here supporting the session. We want to give you a brief overview of our seed funding opportunities and why they are different, how you might be able to take advantage of them or take more advantage of them. And then we also have a number of project teams from the CDI cohort here today who are going to share some skills that they had to learn through their projects and how they learned it. And this is part of a skill swap and networking. And hopefully everyone in the audience can learn from that as well and see someone you might want to talk to later. All the project reps have posters at today's research showcase. And third, we do want to hear from you of ways that we can help seed funding projects go further, because we always hear from them, oh, it's a very bounded amount of resources. We only have so much time. So what can we do as facilitators of these proposal processes to help our teams learn even more? Okay, so remember that there is a notes page linked from the Schedule session, and it would be helpful if you did add your name there. And please, if you are online and there's anything going on, let us know so we can include you in the discussion. All right. Leah, how's the Slido poll going?
We've got 10 votes so far.
Okay, awesome. So what are we going to do over the next 90 minutes? First, there will be brief overviews of the Community for Data Integration CDI request for proposals process. This is something run out of the U.S. Geological Survey. And we'll also have an overview of the ESIP lab opportunities. Then we'll have our Building Technical Know-How skill swap with about 9-ish presenters. And then let's talk about how we can go even further. All right, here's the reminder about the Slido poll. And if you want to ask a question in there, we've noticed that sometimes it's easier to ask a question if you're anonymous or you feel like you don't want to take time raising your hand. But even if you have a question for one of the lightning talks or any of the speakers, you can put that in the Slido at any time. All right, so we're going to get started with the first presentation, which I will give. And this is talking again about seed funding or sandbox opportunities. So these are ways where we can experiment, and it's more of a low stakes environment. We want to also be gaining skills at the same time, but learning from our peers. And here's a few reasons why this is different than maybe your other daily projects. We're doing the split screen. It's very advanced. Thank you. I did that the last session. You never know when you're speaking what's on the screen. Okay, so a few slides. Why is the Community for Data Integration or CDI process different? Okay, we run requests for proposals, and the focus is to solve data challenges and to implement new technical innovations. For USGS priorities, you can have a team, but the lead PI needs to be from the USGS. And this is seed funding. The maximum request is $60,000, and it needs to be done within one fiscal year. So that seems normal, but we really try to involve our community. So the CDI has over 2,500 people on our contact list, and we get together for monthly virtual meetings, and we have Teams channels, and we try to stay as a community of practice that we can ask each other questions and learn from each other. So how is the community involved? When there is a statement of interest submitted, you have to present a 90-second lightning presentation to try to tell the community about your idea. So learning about communicating very briefly, very difficult. Second, something that's really odd or unique is maybe being encouraged to promote your idea to the community before the voting and during the commenting. So we've heard from PIs that are like, I feel kind of uncomfortable telling people to go look at my proposal, look at my statement of interest and vote for it. But we think that this is a good part of the communication training, just like today, communicating in ways you might not be used to within the research science community. There are comments and votes from the community on all of the statements of interest, and that decides who moves on to the full proposal stage. And we encourage the project teams to incorporate those suggestions that came in during the commenting and voting as they write their full proposal. And finally, at the end of this less than 1 year process, project teams are asked to report back to the CDI community during a virtual monthly meeting, and not just products, which sometimes it takes longer than 6 to 8 months, but lessons learned so others can learn from this process and move on from there. Okay, so what are things that we look for that might not be part of other proposals processes? We want you to include team members and new team members and new collaborations. That's something that the reviewers look at. We also want you to be able to succinctly communicate about your idea to a broad audience. This is very hard, especially the first time if you're used to speaking to your discipline, and then all of a sudden you move to an audience that's the entire USGS. It's very hard to keep the jargon down. We would like you to build solutions with the community in mind. So not just for your project, but something that could potentially be scaled. And again, presenting these lessons learned in products jargon-free to a broad audience. We don't expect you to be able to do that right away. And that's why we try to have these opportunities at ESIP, at CDI workshops where you can practice that. The CDI has been using ESIP sessions every other year. When we don't have our regular CDI workshops, you have sessions like this that we think very hard. How can this benefit our awardees besides just talking about their project? So just to give you an idea of the evolution, like the first time that I did this, we just had the CDI awardees just present about their project for 7 or 8 minutes. There was a theme for risk, but it was still not very interactive. So the next time we did it, we used today's topic, which is building technical know-how, and we did the skill swap, which I thought was really useful for people getting to know each other and having a connection to build on. We had one session about communication for technology infusion. So technology infusion is a NASA term for getting the project, the research and development into the hands of the users and infusing it into the users where they can get to it. So there was a joint session, NASA, USGS, and ESIP Lab for lots of practice communicating and having a conversation. So when you go to the research showcase tonight, if someone comes up, say something briefly and then ask a question so that you can connect to your audience and figure out what is that connection point that would be most useful. And then a couple years ago, we had a session on making collaborative decisions. So that one was also a very broad one that might be helpful to you and your project team. So there's links to all of those resources. And also noting that at the poster session, we encourage the better scientific poster format, which is a very pared down poster format. Also very difficult for people to follow the first time, and some people like it, some people hate it, but it's just giving you ideas for how to best communicate to broad audiences. How am I doing on time, Leah?
Okay.
What does that mean
13 minutes in.
of when I started? Okay. All right, well, here's just a few examples of some of the projects that will be on a poster that Leah has tonight. So some examples are examples of how to use USGS APIs for geospatial and topo data. It's really great to see the examples of that. There is one on tools and interfaces for better working with geophysical data that is in the NetCDF format. There are some examples of using LiDAR and open topography data and how to display those and work with those. And we also have projects like lessons learned for building decision support tools, which is very important within the USGS. So there's an example publication on that. All right, so this is just a list of the different projects that have representatives here today that you'll hear from during the skill swap. But with that, that is just an overview of our process, how it's a little bit different, and kind of background and motivation for why we're having this discussion here today. And I'm going to pass it off to Aaron Fries, who is the ESIP lab director. And we are always looking for opportunities to better connect our programs.
Thank you, Leslie. All right. Yeah, so this is my first attempt at giving an ESIP lab presentation. Really not much has changed, but essentially ESIP Lab is kind of a subset-ish of ESIP at large. So everything you do in ESIP Lab kind of plays into what we do at ESIP as a community, or having the community as our backbone. So again, my name is Aaron Fries, ESIP Technical Community Director. Also kind of manage or not kind of, but I also manage the ESIP Lab activities. So we'll be covering, what ESIP Lab is, or how I think it works, how to build skills, and why we focus on that, and then how to engage with us. All right, so ESIP Lab is, I like to think of it as kind of an innovation engine, but part of that is, and a big part of it is the skill building. We see it as a co-equal partner to the actual innovation engine or component of that. And so really, in addition to just the focus on building skills, this kind of space gives you access to kind of emerging tech that you can kind of play around in a sandbox at kind of a low risk. So it really kind of attempts to find those or be open to those who either have hard time accessing certain environments or just have under-resourced kind of spaces that they work within. So repeating kind of that, it gives us gives people access to what you would otherwise have trouble getting access to. So early on, say cloud resources, when we started to look into that, there was not really infrastructure or the ability for a lot of people to get in there. There's some hesitancy to get in there. So this is really a nice little sandbox for y'all to maybe take advantage of and just kind of explore and build skills in different areas. There's always a technology advancement going on. I think right now we're kind of in the cloud native or cloud native data, cloud native workflows, AI, LLMs. So really, you have the access to our resource to really explore that. And the space has historically been used to really advance the cloud native aspect of technology right now. And I think it's starting to be used more and more for exploring how to use LLMs within the cloud for users to kind of explore or build up infrastructure, run it down real quick. So some of the things we offer, we like to think that the ESIP Lab is kind of an idea to action, but it doesn't need to necessarily go all the way to action. It could be an idea to failure, and that's fine as long as you're learning something. Like I said, it's part of ESIP. So you get the support of the community, you get the support of the staff in certain activities. So if you're building workshops out and you need some assistance, we're here. Challenges, hackathons, we have expertise in planning and executing those. Really what the two ESIP lab unique things are the digital infrastructure and the seed funding. Digital infrastructure comes kind of in the form right now of AWS, the kind of collaboration tools that we have, and then also GitHub. And then we have the seed funding, which many would be interested in, things like the Funding Friday and the lab grants, and we'll touch on that in a little bit. Community is the backbone of ESIP, and you got that at your backing. We can definitely assemble reviews or assemble different types of evaluations throughout the community and see how if we can kind of take that from an idea to an actual application or something that's being adopted by different agencies. What do we got here? Okay, yes. So ESIP requires in our request for proposals a learning objective. So it is something that is scored within the RFP, the request for proposals. It's something that we value in the Funding Friday. So really, whether you're early career, whether you're a seasoned scientist, there has to be a learning component in anything that you do with us. And so kind of following that, we want to be a little bit better at kind of documenting and identifying kind of what they learned and being able to pass that and share that to the community. These are kind of the areas that you can interact with us. Funding Friday is an in-person seed funding opportunity. This will be held, of course, this Friday. This year, we're offering $5,000. We're offering 5 awards at that number. So actually 6 awards. 6 awards at $5,000. So it's a great opportunity to just get an idea, test it, and see what you can come up with. And so that's just a little plug here. Thursday, want to try to assemble your teams and get your ideas down and start creating the posters. Friday is when you present on at 8 a.m. at the Zlotnick Ballroom. Our request for proposals, this is a little bit more of a commitment. It's a $20,000 award. We haven't really narrowed down how many awards and what the award is yet, but it is in process, and we will be announcing that in the future. This is a little bit more rigid. This is a formal competitive grant that you submit a proposal for. It gets reviewed and then assigned out. And then you get about a year, 9 months to a year to act on that funding. And then also the more kind of informal process is just open invitations. If you are engaged with a ESIP partner, or if you're involved in any of the collaboration areas, you have something that you're interested in. I want to be more aware of how S3 and EC2s work. Feel free to reach out. My email is up there and is at the end. Reach out. We can discuss, see what we can do and how we can help. And then, I think before of our digital infrastructure, you got to plug that AWS has really been a great partner, really indispensable in allowing us to have credits for people to really learn from and explore without being a heavy burden on us. So, just a plug there. In the next 3 to 5 years, we want to still be here, but we also want to be growing and become like a prominent, recognized force in earth science innovation. We want to keep on building some partnerships, look for different opportunities for funding, and kind of deepen our connections in the application space. So really look for opportunities to go from that idea to adoption and figure out how to get those ideas to scale. continue to be that skill building space. We want to keep the barriers low so people can gain access. And again, it goes from early career to seasoned scientists who may be struggling to get access to those resources in some way. And then finally, keep bridging between our partners, our government agencies, academia, industry, keeping everything kind of in the open and making the connections to see who could kind of benefit from certain solutions. And so this is just review, and I think we'll go.
Should funds go to non-federal in general, right? So if federal people have collaborators, is it true that the funds basically are meant for non-federal?
Non-federal and people who are allowed to work in the United States.
Okay. Okay, thank you, Aaron. So that was just a little bit of setting the stage of we really want you to be learning throughout this whole process. And even if you weren't invited here as as a project rep, I might be able to go up here and change the tab. Where's all the tabs, Aaron? Escape. Okay. Yes. Thank you for those who have answered the Slido for why you joined this session. See, computers.
Take over screen share.
I think Leah can just take over screen share.
There we go. Okay, you can come out of it, but you can't go into it.
Where did all those tabs come from? Okay, yep, right there. And the next one. Okay. Thank you. Gosh, when we have to get back, how are we going to do that? All right, this is going to be, we're going to move into the skill swap, which is going to be very dynamic. There will be people coming up here and talking for 2 to 3 minutes. But why are you here? Then what are all these others? We would be interested if you did put other to either you could put it in the Slido Q&A or you could raise your hand if you have why did you put other? Not I was asked to be here. I want to leverage outputs of seed funding, or I'm interested in applying. Anyone want to share their other?
I was just interested in the approaches that you all took for the seed funding. So with CDI, it was really interesting how you did that letter of intent. You had people come up and give lightning talks to do their presentation. I had more questions for you, Leslie, about how that process worked, what the time duration is, what the commitment is from reviewers and things like that. But that was why I attended, was to see how you all are approaching these types of things if we wanted it. So I'm sorry, Matthew Biddle, NOAA's Integrated Ocean Observing System Office, and we have different funding proposals that go out. And so I'm interested in more of that side of the conversation.
Any other others?
Hi, I'm Lorraine with Esri, and I put other because I'm just interested also about how the funding is made available to others and how perhaps maybe a commercial company might be able to partake in ESIP Lab. I've always been interested in that, so that's why I'm here.
That's great. Does this mic connect to the online? Yes? Okay. All right, I'm just, because I was talking. Thank you for sharing that. And I'm glad because when we were putting this together, we were like, wait, are there NOAA or NASA programs that we should ask to contribute? And it's nice that you might be able to tell us what you want to know and how we might be able to connect in the future. Okay. We're going to get to the skill swap, which means we're going to go back to the slides and get a timer. And the mouse is here, and the slides are here. And here's our first one. I shared it in a way that no longer has the notes here.
If you need notes, I can get them back.
Okay,
Notes?
but do you think you could do that quickly? Like you need it for subsequent slides, right?
I'll wing it on the other one.
No, we don't wing it here. We never wing it. Just kidding, we always wing it. Okay, so we're going to have 8 in-person speakers, and I'm going to get my timer, and it's very informal. We just want to learn, usually it's through your project, a skill you needed to learn for your project and how you learned it. All right, so I'm not going to touch that, but Lauren, would you like to come up first? So if you could say your name and then just launch into your slide. I know it's small, but you can see it up there and over there as well.
Okay, sounds good. Good morning, everyone. I'm Lauren Koenig from the USGS. I'm here representing our stream metabolizer CDI project. And the title of the lightning talk is Scientific Support on a Shoestring, because that's our skill, is we want to learn how to do that. How to do that better, how to support open source software. So Stream Metabolizer is a USGS-led software library that makes estimation of photosynthesis and respiration rates in rivers accessible. And it does that by providing users a number of ways to fit statistical models, ranging from pretty simple to pretty complex, to field observations. And it also provides a number of model configuration options that can be tailored depending on the characteristics of the study system. So in our CDI project this year, we're implementing a new research method into the software library that allows us to estimate photosynthesis and respiration rates in a wider variety of rivers, specifically in rivers downstream of dams and reservoirs, which are usually really important to kind of water resources, scientific questions and management questions. So to do this, we need software development and release methods that first and foremost promote long-term usability and understanding for our end users, but that also promote sustainable development patterns, sustainable maintenance patterns for our developers. And then finally, to kind of align with evolving technologies and USGS software policies. So specifically, this year, we're updating dependencies and syntax. We're developing test data sets and documentation to help users apply these new methods in their research workflows. We're developing unit tests to ensure code functionality. And we're also experimenting with providing Docker containers as a way to help users understand and then, of course, manage the dependencies associated with different versions of the software as it evolves. So how are we kind of learning these skills? I know I've benefited from some kind of open source resources or more formal resources like books, but I think the biggest asset has just been learning from the kind of diverse skill sets in our project team members and the experiences that we bring to the table, as well as the experiences of colleagues that we have at the USGS that have experience kind of releasing open source software for the scientific community. And so, we appreciate, and perhaps you do too, that developing and releasing open source software is not just a technical problem. So we're trying to kind of continuously learn and talk about how we minimize the maintenance time required and maximize the opportunities for to support users into the future beyond the scope of any specific funding cycle. And so with that being said, if you have ideas, skills, or experiences developing or even using open source research software, I hope you'll come chat with me at the poster session. I would love to talk with you. Thanks.
Yeah. All right,
There you
great.
go.
Yeah. Hey, everyone. I'm Boyan Malinik, and this kind of instruction about how to use Quarto came out of the funding that was the project that was funded from this was what they forgot to teach you in Python 101. So it's just kind of a material in order to teach people how to use Python. And the idea behind the using like Quarto Live was that it's easy to get tripped up whenever you're trying to run Python for the first time and just get hung up on setting up the environment and all that kind of stuff. So the idea was to kind of get people's hunger going by like running some code and making figures and changing figures really quickly in a browser without having to set up the Python environment. And so did a little bit of deep dive into Quarto Live, which allows you to do that. And the real solution to setting this up, honestly, is using Quarto Live and then hosting it with GitLab or potentially GitHub with a like GitLab runner or GitHub action. But it turned out to be a lot less complicated than I expected. Like it'll host the website for you. Like it's a really clean process. I thought it'd be I just thought it would be a lot tougher. And something to add about this I found really useful about, the buzzword of AI is it's great when you're using like a agentic AI that can look at all of your files and just say, one of the big things to get it set up in GitHub or GitLab is just having like a text file formatted the right way and pointing to the right places. And the AI helps so much with I think that's the hardest part, and it helps a lot with that. So if you're creating any kind of lesson material and you'd like to get people, I guess, to use that lesson material without all that heavy setup of getting a Python environment set up and all of that, highly recommend Quarto Live. And me and Chris Sherwood here will be having a poster session more about that lesson material. So love to be back.
Thank you, Boyan. And it is helpful to know to share things that do work within the USGS computing environment as well for those of us who have to stick to that. Okay, Quarto Live. All right, next up we have Mike O'Donnell.
Hey, so my name is Mike O'Donnell, and I work for USGS Fort Collins for the ecosystem submission area. And I am working on a project using AI for literature synthesis, structured literature synthesis. So our goals are really to determine or investigate the use of AI for reading through literature. And this is important because it helps us identify scientific gaps, data gaps. We can use information or acquire information more quickly that can inform policy decisions, NEPA planning, and other land management needs. And as I had mentioned, the big goal is really to essentially determine how well AI can improve the efficiencies of doing these literature syntheses due to the exponential growth of literature. There's a lot of information to read. They typically take very long time to do this. And so can AI help us with this? In terms of technical skills, a lot of it was really about learning a lot of the jargon surrounding it. So natural language processing, large language models, You've got NER or named entity recognition. So all these terms that kind of surround this environment and how can you incorporate it and use it. And our process has been to really develop a workflow software, be able to integrate and tie into different API calls for these large language models, but then also use local large language models on USGS computing sources that use GPUs. And that is really so we can better understand how different models may help, as well as the benefit cost analysis, or how much these resources would cost if we had to pay for it. And in terms of learning a lot of these skills, for me, it started back in August with the class offered through USGS, but mostly it has just been reading literature. I have a strong background in Python programming, so in terms of the API calls and being able to tie into different libraries and stuff, I have a pretty good sense of all that. But also, I have been talking with a lot of people, presenting our efforts, getting feedback from people in terms of what they're doing on this topic and how we can learn from each other.
All right, thank you, Mike. And we've heard a couple of times already that speaking to our colleagues. Okay, and next up we have Coral.
Hi, my name is Coral Howe. I'm a geospatial analyst for the Lower Mississippi Gulf Water Science Center, but most of my work in the last 3 or 4 years has been with the Chesapeake Bay program. And working in those meetings has been enlightening because you ask for 5 people to define catchments, you get 7 definitions of what catchment is. And these terms are used interchangeable. And there's a big interest in using AI tools to facilitate finding data that will support decision-making for managing the watershed and controlling water quality in the Chesapeake Bay. But it's very confusing for humans to understand what people mean using different terms. It's even harder to get AI and large language models tools to understand what we're trying to ask. We use the same word, but different meanings, and that meaning is not necessarily explicit when we're talking. And we interact with a diverse community of people, from the public to managers to counties to NGOs, and then regulatory people. So it changes drastically, and enough is enough. We want to push to the idea that we need to make decisions of what we mean from these terms, or the different definitions that they mean, and make them explicit and relatable to other terms and concepts and context. So when we go and start implementing large language models to facilitate search, we can actually get information that will be useful instead of having to go through 10 Google pages to find the one data set that is not going to be useful. That's all I have.
Thanks, Coral. We're excited about maybe getting you connected with more of the ESIP community that's really interested in these topics, and you might become the next USGS. Who do we talk to about semantics? Okay. Next is Hazel. All right, timers.
Hey all, my name is Hazel Mebius, and I'm a contractor through KBR to the USGS Aero Center out in South Dakota. And the tool we made was Field Table, which is the goal is to create paper field notes that automatically convert into electronic records using AI. So we've all field crews are sent out, and then they come back with a stack of field notes that then somebody, usually me, ends up having to go and enter them in digitally to Excel so that we have them. So we were wondering, with these handwritten field notes, are we able to take a photo of the sheet and then enter them, run it through AI, and so then it's entered into a database-ready format, usually a CSV? So to do that, though, one of the main problems we came up with is a pipeline that can read both structured and unstructured notes. So with the tables, it's really easy to have the AI go through, scan it, pull out which column and row needs to go in which CSV. But then you also have notes, which are just people sketch down because in the field stuff happens and you just want a little note. So that also is harder to pull out. So the solution to this, we used an open source optical character vision module recognition model, Light on OCR and the GLM. The Light on OCR is really good for tables, and then the GLM was very good to notes. So if you combined both of them into one Python script that would parse through all the data, you could then get an outputted CSV that both works well with both unstructured and structured notes. How this kind of learned, a lot of reading about the Hugging Face Transformers, which is an open source vision models, documentations, talking to colleagues that actually have experience and have done this before, usually the most helpful. And then again, lots of testing against the original scripts to tweak which data sheet and field notes is most useful for yourself. There we go.
Yeah. All right, morning, everyone. Sean Thibodeau. I'll be highlighting how our CDI group, the USGS IoT ingest stack, leverage things like infrastructure as code practices to more easily and rapidly deploy things like cloud resource stacks for scientific applications. So a little background, I work for an urban hydrology group out of the Upper Midwest Water Science Center in Madison, Wisconsin. So we're really focused on like stormwater issues, specifically like urban flash flood risk. So we have a monitoring need for these really densely located and like real-time, rapidly transmitting sensor data, precip and stage data. And so we have looked towards things like low power sensor networks that can rapidly transmit data into the cloud. This is commonly referred to as like smart Internet of Things technology. So this has been really useful to us, but it has been a bit of a challenge for people who are not native to like these types of cloud deployments. Specifically for me, we had to manually try to create these cloud stacks for these cloud ingest pipelines. And that is very time consuming. So this project has really been trying to generalize that, standardize that for people who are also interested in these types of IoT cloud ingest networks. So using these tools like the AWS CloudFormation resource or other platforms have some similar things, but these can really, really simplify definitions of complicated cloud stacks that can, greatly streamline these types of networks for people who are also interested in these types of deployments. So I would say there's some awesome resources online for if you're interested in this, but for people who are not really steeped into these types of cloud environments, I would say get your foot in the door with a popular platform like AWS. Start messing around with just the resource components, seeing how they work together, and start to build up these stacks, and then get into these infrastructure as code tools like CloudFormation, and then also things like the Cloud Development Kit that can help you programmatically integrate things like unique sensor configurations into those stacks. So like that's really what's making this generalizable to other teams. So thanks.
Thank you, Sean, and thanks for adding some links there in your slide as well. It's good to go back to. Next, we have Brandon.
Thanks.
It's your time.
Perfect. Hey, everyone. I'm Brandon Waters. I'm from Colorado at the Colorado Water Science Center. Our project is Ice Edge. Do I need to take a step back? Yeah. Our project is Ice Edge. We're basically trying to improve winter stream flow accounting. Right now, I think in January, we had something like 14.5% of the USGS active stream gauges were affected by backwater from ice. So we're trying to improve that real-time data. And I guess, reduce those estimations. A big challenge we had with this project is we were trying to use existing equipment to quantify velocity under ice, and we were taking a raw ASCII data stream and trying to ingest that, do some edge computing, and provide some data in a usable format for us back in the office. So the big challenge, I have that flow chart on the right. That's really what I want you to focus on. We're focusing on that stream side edge computing. That was something I had never really worked in. I didn't really have the Python background I needed to do this. But we developed a couple software packages, ADVMcom and a probability concept MicroPython script that we were able to run off of Raspberry Pi. And probability concept method is the method we're using. It's like there was a techniques and methods that was released in 2025. So it's a relatively new method, essentially creating a model for, I won't get too far into it because you can come to my poster presentation and talk to me about it later. But essentially we had the need for some stream side edge computing. I used a lot of AI's help and my colleagues around the USGS to help me develop the skills and the scripting prowess that was needed, and also come up with a usable interface on the Raspberry Pi to collect this data real time. So right now, there's a demo of the box we set up. We're ingesting the ASCII data stream over DB9 RS-232 input. And then we're doing all the edge computing at our site, a lot of times in kind of extreme power conditions and weather conditions. And then we're transmitting that back to our office over a SatLink 3. So 2 different suppliers, 2 different vendors, different data streams. How can we bridge the gap? And CDI has been helpful for us and given us the support to dive into that when we wouldn't necessarily have the hours or funding to do that otherwise.
Okay, thank you, Brandon. We have one more speaker, Chris, and I just want to note, you can see the diversity of the data types and the types of science that these projects are supporting, and it's similar in range of what we see at ESIP too. So being able to figure out what are these skills that might be transferable to even other disciplines is important. Now, I saved Chris for the end for a specific reason, but when I looked at the slides, no one had really put in how learned, like, well, I asked AI to help me until Chris's, but now in the presentations, it came out a little bit like, yeah, maybe Copilot was a little bit helpful, but this is maybe part of what we will have a discussion about, is that we all need time for learning, and learning is evolving a little bit. So how can we continue to support learning when people kind of have this image that they can go and learn anything? But let me stop talking and move on to Chris's slide, and I'll reset this timer for you. And you can please go ahead.
Thanks, Leslie. I'm Chris Sherwood. I'm a research oceanographer. I'm in Woods Hole, Massachusetts, on the Woods Hole Oceanographic Campus. And I'm working with Boyan and Justin Myers on a project to basically improve. We teach Python using the software carpentries class, but it's not designed for earth scientists. And so we are kind of enhancing the curriculum by making Jupyter notebooks that provide a little bit more earth science-y examples of how to use Python and teach some of the things that aren't taught in Python 101. This was part of a talk that I had to give. And so I've been using AI a lot to develop the class material. I ask it for prompts on, for instance, give me a summary of how to use NumPy for scientific things. This is a little bit different. This was me giving a lecture on wind-driven flow in a very shallow lagoon because it causes flooding. And I wanted to have an animation of that, and I didn't have a model. And so I asked ChatGPT to write me a numerical model. And you can see the prompt is pretty technical. I'm an oceanographer. I'm a modeler. Numerical model is a one-dimensional time-dependent solution, blah, 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 right? Very detailed. But I was shocked by how good the code was. It produced a realistic model. It was well coded. It ran beautifully. the graphics were, I tuned the graphics up a little bit, and I ended up, and I wish I could animate this, but I wasn't sure that would fit in this. But basically, the wind blows the water over to one side. If you just stop the wind, then it kind of settles down. But if you switch the wind the other way, then you get this big slosh coming back. So I've been using ChatGPT. I've been using Claude, Copilot, and I've been doing a lot of different things with it. But what I certainly think that it is best at of all these things is writing code. And I've even given it a model. I've given it a PDF of a scientific document and had it write a successful model from that, scanning the OCR from the PDF and writing a model. And if you're not using it, you should at least try it for some of these things. And it takes practice. Thanks.
You're back up. So Aaron, could you take about 5 minutes you have 4 slides here with examples from ESIP Lab, and if you could take about 5 minutes to go over some key points that we could learn from these other projects?
Yeah. So I wanted to kind of first touch on ESIP labs are like we develop a solicitation, basically built up a theme. We coordinate with our government partners to identify areas to kind of look into. And so all of our kind of cohorts from year to year are all based off kind of a similar theme. This one was kind of before my time. This was the 2024 cohort. It was based on climate, communities, and resilience. And so all of these took different approaches for different areas to really, create dashboards, create models to do some climate resilient thing. Now, I'm not going to do any of these projects any justice because I'm fairly new to them myself. But here we have the first one that I wanted to highlight was a climate resilient dashboard. Up in focused in the Appalachian Mountains. And so they were looking at ways to use LLMs to be able to submit queries that leverage government GIS data and GIS processes and identify areas that are at risk for certain kind of, say, flooding events or how close you are to a hospital within the county that you could, or that's it would take the shortest amount of time to get to. And so they went ahead, they gained skills in really working with LLMs, identifying the GIS data layers, and then kind of went back and forth with ESIP community members to refine the process. It's not a operational platform right now. They are still kind of developing out, but we at least were able to kind of get them off the ground. I think this one's the next, but this is kind of a little bit closer to citizen science. They were working to identify, areas in underserved locations, specifically areas of color. They were inserting or planting temperatures, so identifying or temperature monitors. And so they were leveraging the classroom environment to learn about these devices, learn about kind of the envirosensing capabilities, going out and placing them in their locations and kind of comparing that to like the broader models that you see where what do we got? Urban heat environments and how coarse that is compared to what that is, what they're able to get from the sensors. And then we had another individual who was looking at building a social vulnerability platform that leverages cloud direct data. And so he put together a Shiny application, leveraging AI to learn about how to deploy the Shiny app. Gives a great kind of user-friendly, intuitive platform that gives you nice little graphs on the fly, has good access to data layers that will kind of give you an idea of where what locations are kind of under threat, given kind of the climatology of a space and the social and demographic data underlying it. And so these are the ESIP lab solicitations. The current one right now is democratizing AI, which we have a couple projects that would be of value to some members of this. We have one that leverages AI to create lesson plans for teachers, which is kind of similar to what you were talking about. And so I see a lot of connections between either labs or the collaboration areas within ESIP that we can make those connections between CDI and whatnot. I wanted to give kind of how much time have I got?
1 minute.
Okay. Personal story. Shout out South Dakota. That's where I'm from. I worked KBR. But the activities, this is a kind of an informal activity that took place. It was related to the cloud analytics group that we have within our collaboration areas. Rick Sidnell, I don't know if many of you know him. He's kind of a very good innovator, let's say. Did a lot of work in the early kind of cloud adoption time with USGS, NASA, NOAA. And a lot of the work that he did within our lab, within the AWS space, he took back to USGS and really built out the cloud environment and identified services that we needed to do. We need to deploy Jupyter notebooks and got that Pangeo environment that many of us have used, really kind of built my foundation in working with cloud assets and understanding what you could and could not do and trying to fill those gaps. And so this really was instrumental in my kind of progression in cloud and into this role as I am right now. And it has just a very broad reach to it. Reached, what do we got? It's very small, 128. These are kind of soft number, but 128 members had at one time used the Nabari instance that was a Jupyter Hub, basically instance that was deployed in our space. They had 4 years of runtime. And then also touched all the major partners or the government agencies, NASA, NOAA, and USGS. And so it's a massive success story, I think, in the utilization of our lab resources. And we'd really like to keep it going.
So talk to Aaron if you want to learn more.
Yes.
Thank you. Okay. We have some questions that came up in Slido, things which is like project to project. And Leah, I'm wondering if you could read out those.
Yeah, so the first question is for Hazel. Was your AI ran fully locally? And would that be the intended use if made available to the public?
Yes, the AI was run locally on your computer, and then the goal here in the next month is we'll upload all our scripts with documentations up to a GitLab, and it will be fully available and all open sourced for anyone to use.
It'll be available, but it was important for the USGS to have it secure and locally run.
The next question is for Sean. Do you think it'd be useful for lots of people in a single team to learn the whole AWS set of tools, or is it better to delegate to one expert?
Yeah, if you have folks that are already familiar with a common programming language, I would say that they can spearhead that effort. But it is definitely helpful to have people bounce ideas off of, to bounce ideas off of. I definitely have folks like that on our team. But yeah, like it can be useful in both scenarios to have someone run with it or to work alongside folks. But yeah, also having people, advisors has been really helpful who already know these components of these complicated cloud platforms. Definitely helpful too. So.
Thanks. The next question is for ESIP Lab. Is the code stored in a central location, and is it eventually made public?
We try to encourage people to put it in GitHub, essentially. And so whether it's in our organization or if they decide to have it in their space, we want to have a link to it at least so that we can use that open information. One of the objectives is to have that as open source code. So.
Thanks. The next question is for Aaron. I enjoyed our brief interaction to run the Python script in the ESIP GitHub. What options are available to create a sandbox for us to test in? Some scripts need to run every 1 to 3 hours and will support oceanographic and meteorological analysis for this hurricane season. Thanks.
One of the options that's like currently running that I've kind of played around with is just using code spaces in GitHub and GitHub Actions. We have a repository that runs, I think, every 5 minutes right now. So it'll deploy an action and go and run and grab the data, bring it into the repository, and put that, I'd have to check my notes, but makes that available for an application to pull from. The ESIP, say like ESIP AWS space, I'll mention that it's not an operational space. So if you do start solutioning out there, it is intended to be a sandbox and an exploration space with the intent that we'll try to work with you to offboard it in some way once you get to that point. But for right now, I would say if you're looking for something that right now to regularly run, code spaces in GitHub is a great option, but there may be other options out there.
Thanks. That's all the questions in Slido.
Question, but just wanting to.
Yes. Okay. Do we have a question in the room?
I have a question for Chris and for Mike. I guess, what's your feedback on how the large language models work? Do you have a sense of which of them works best for images versus just code? My experience, for code is pretty good, Claude, but then it's not visually appealing, or the text is too small, or there's always issues for human accessibility. So I was interested in feedback from other perspectives.
Well, as part of that one that I did, I tried to get ChatGPT to make me some figures to kind of demonstrate. They were terrible, and I spent way too long. It's very slow generating figures. So I found another thing that I did, and I was doing an internal USGS peer review for a journal publication. And I asked the author if it would be okay for me to run it through. So I ran it through Copilot. I gave it 2 different prompts. One was basically, I'm a subject matter expert, and I'm doing a scientific peer review of this. And please give me that. And the other one was, I'm an editor, and I'm interested in the writing and the grammar and that kind of thing. So I gave it 2 different prompts, and I gave that to Copilot, ChatGPT, and Claude. That was the order. Copilot was the worst. ChatGPT was better, and Claude was definitely the best at both those prompts. And I have to say that we all have to, all the RGE scientists have to publish things. I totally recommend running it through because it gave some good scientific advice, and the code and the grammar really helped too. So those are 2 things that I found it very useful for. I don't use it much in doing research, but coding is great because you know when you get the right answer, right? So and it seems to write good code.
You had a question for me as well. Is that correct? Yeah. Okay. I would say, so I've been testing different models ranging from Claude to Gemini to the ChatGPT or OpenAI models, as well as local models. I'm still testing some of the local models. And not to highlight, I don't want to state one is better just than the other. But from our testing, we do have clear separations in terms of which models, at least in our application, work better. It's also really interesting because our prompt is pretty complex. We have used multiple AI models to help us write the prompts, and it has been a very iterative process in terms of like trying to obtain the response and the results that we are expecting, and so. With that, so like our prompt, for example, is 5 pages, and which is a lot. And there's a thing called context rot, which basically means too much information can result in worse results from AI. And but what is interesting is that was not the case with our prompt, which I was completely surprised by because I was going to assume that it was going to be an issue. So, yeah, I would say there are differences. I think it helps to kind of look at some of the leaderboards so you can get at some of the accuracies of different models. These tools or resources are online, and they can be really helpful in terms of which models may do better at certain things, as well as which models are more accurate.
Thanks, Mike. Okay, we are going to move into the last part of this session, and thank you for sharing your experiences. I think sometimes having to put that into words like also helps yourself focus some of your messages. So this next part is how can we go even further with innovation seed funding? And please, I know it's like towards the end of the session, but we're going to end early. So if you could help us just gain a little bit more data from you, if you could please either go on your laptop or your phone. And we talked about, our 2 processes and how seed funding is really hard. There's not enough time to do everything. And these are topics that potentially we could help our projects learn or hold sessions about them, give you more resources. So there's obtaining user input, increasing awareness of the project to the users, and planning for sustainability, because it's called seed funding, not sustained funding. So if you could put some input in there, or if anyone has any comments about where they've had the most challenge or they've seen the most challenge from other projects, or if you're like speaking for a friend, if you don't want to admit anything for your own project.
Like for me, I guess it's the idea that these large language models are going to solve our semantics and bring lightness to how different we communicate. It's something that I guess I struggle to communicate to other people. That is not necessarily the case. And especially in the regulatory context of the Chesapeake Bay watershed, there's this idea that they all talk the same language and each state has their own criteria and definitions of what is good water quality, but that doesn't necessarily translate in these large language models. Like it's not transparent.
Okay, so that's like a general challenge that you want to solve. Okay, great.
I guess perspective from other folks.
I will say that there has been some work within our clusters that have looked into semantics and using large language models for semantic activities. It's very early on. promising work, but yeah, like you said, it's not solving it like that. It's actually making them question, what decisions were made, and then, really kind of giving them, good advice in some instances. So it might be worth, looking into or connecting you with those groups.
Hi, yeah. I would say for creating something like a generalizable tech stack, having like things like community of practice groups for a conduit for user input was extremely helpful, especially when there's like only disperse and smaller teams working on things like Internet of Things or IoT telemetry, to have the most feedback on what people are doing and how they could use something like the tech stack we're creating.
So you're saying you did use an existing community practice
that's
to interact?
Yeah.
Okay.
Yeah, sorry.
So keep the communities of practice.
Yeah, or expand. It was extremely helpful. Yeah. Or, I would say that aspect of it was just a really important part of our project.
Thank you, Sean. I just was sighing at the drop down. Okay, so thanks for that input. Just talking a little bit about the trends that we saw in the lightning talk. So a lot of learning from colleagues and teams, a lot of looking online at tutorials and videos, trial and error. And we talked a little bit about what we might help with. I'm wondering if anyone here, by show of hands, if you had heard of the SGCI Science Gateways boot camp for sustainability. It was around like 5 to 8 years ago. ESIP and CDI actually had that boot camp for sustainability to some of the project cohorts, and it sounds like that material may be useful to bring up again. We have one more data collection. How do we do this? I think there's one more Slido. Okay, so given that one of the trends is learning from colleagues and teams, and we also heard about using AI to help us learn, okay? So I have been asking this question to people like, well, now I'm afraid to ask a question during a meeting because I should be able to just ask it online and like the AI summary should basically answer it for me. Okay, so I'm afraid to ask things because people would be like, oh, you can just look it up. But I think there's an important distinction that that answer will give you like information or a definition. But if you ask the question actually in person to people, that can actually help clarify, help clear up misunderstandings or something like you weren't sure how it related. So I want to say it's not like you shouldn't ask people anymore because you're like, oh no, I could just look it up on the internet or AI now, but actually the human connection is still important. All right, so there's a question about potentially co-working or putting in time, because now that we're faced with, oh, we can learn anything by just asking it. How many times have you been like, oh, I can just ask that later, but you never get around to like answering a pretty straightforward question by looking it up. So I think that one way that the one about co-working, there's a question about the co-working, maybe.
There's no co-working in any of the.
Okay, yes.
Sorry.
This one? Yes. Okay. It doesn't have the word co-working in there, Leah. Sorry. If you could spend a couple of minutes thinking about or just putting something in there about what might you go to? Because I know in these questions you're like, oh yeah, I might go to that, but you might not go. So let me explain what a organized learning session could be like. It's like, there's a couple questions I want to look up and research online, but I'm not going to get to that unless there's like set aside time or your cohort were like, hey, everyone, Friday for 30 minutes or an hour or sometime this week for 30 minutes or an hour, block that off for learning new skills that are related to your project or something that you want to do. So a couple things that you could just put in quickly, like Do you prefer asynchronous, like do it at some point this week, or synchronous, let's all do it during this 1 hour or 30 minutes? And do you think that you would actually put aside an hour or even 30 minutes to spend on skill building? Is that enough? Because we could experiment and see, like, oh, if we set this up for the project, for project team members, does this actually help them? Because we'd just ask you to report back, like, oh, one sentence. Today I was looking up such and such skill and I found this resource. That might be a way that we can amplify the asking colleagues or human contact or sharing. Sometimes this is called like work out loud or sharing what you're doing. It might be an experiment that we do because we like to experiment and see if things work or not for our cohorts. Okay? So thanks. Well, thank you for putting in your thoughts. Take that and see if we can do something in the next few months while you finish up your projects here. And it might be something that we like decide what the scope is. It's nice having a scope. You've all now met each other, so you'll be more likely to be like write something into the teams, because I don't like putting messages in teams when I don't know who I'm talking to. And it might be a way to keep going further and leverage our communities. All right. Are there any other questions? Okay. Aaron, come up here, please. All right. We really appreciate this because, again, providing time and space, we wouldn't be able to do this for the project reps that are here without the ESIP meeting and the ESIP space, and hope everyone here learned more about the CDI and ESIP opportunities and how you might be able to leverage those. And we would be interested if you know of other similar things that you think we should be talking to in NOAA or NASA so we can align and try to build on each other. Okay, Aaron, what do you think of this experience, these past 90 minutes?
It's good. We've always kind of looked for, we've mentioned ways in which ESIP and the CDI could connect. I haven't been very good at making those connections, but just listening to even in the CDI calls. You've been here
for like a year and a half or something, so.
But in here and even on the calls, it's like, yeah, there's a collaboration area that could potentially be helpful. When it comes back to how much time are you willing to spend, because that's another hour out of your already pretty busy day, month, what have you. Collaboration areas meet monthly, most of them. And so you could plan for that, but I could definitely see where in CDI, you're leaning a lot on USGS, these close partner or your colleagues within the CDI. ESIP, I'd like to say, has access to the entirety of the earth science realm. And so I think being able to reach out that broadly is an advantage, and I think people should take advantage of it. And so I'll be revisiting and reaching out to some of y'all to see if you'd be interested in, say, presenting, and then that's usually kind of the gateway in.
Presenting, yeah.
Is doing a quick presentation, seeing what it's about, jumping in on another one, and hopefully you get hooked. And that's kind of where we're at there. And that's not just an ESIP lab thing, that's ESIP in general.
Thank you very much, Aaron. Thank you, Leah, for helping us to coordinate everything. Thank you, Dave, online. Thank you to everyone who came in. Hope you learned something. And we're going to take a quick picture for those of you in the front row. Okay, but thank you, everyone. And you can go beat others to lunch. Yay. Thanks.